Today we will start the demo again for one-way SSL and two-way SSL. So let me show you that slide first. So this was one-way SSL. We need to implement that first, like in MuleSoft. So let me share my Anypoint Studio. This was the Anypoint Studio. This was the application that we were using during the database integration, right? So what is this? Okay, it's very hold on. So today we will implement one-way SSL, two-way SSL in this same application. So first I want to show you some commands that I will use. So these are the commands that I will use. Okay. So in one-way SSL, we will use these three commands. In two-way SSL, there are more commands that is these commands. Okay, I will show you that later. So first in the one-way SSL, we have three commands. So first will be generate server key store. So with the first command, we will generate key store. Okay, and with the second command, first we will create the key store, and second command we will just export the public certificate from key store. Okay, and this key store will be I will write it like generate server key store. Okay, and here from server key store. Okay, and third command will be for importing server public certificate into client trust store. Okay, so these three commands will use. I have deleted all the files that last time I created. Okay, so I will open the command terminal first. So what we will use for to create in this, we will create a Java key store JKS file. That is JKS means a Java key store, and a Java key store means it is a repository of security certificates. Okay, so we will use that, and it use a key tool utility that is inbuilt in our Java JDK. So let's open the command window. It opened this command window, and here we will use that key tool utility to create our key stores. Okay, so one moment, I will allow more people into this call. Okay, so very first command, let me copy this command and paste it here. So here we are using key tool, generating a key with alias name mule server. Key size is this. Algorithm we are using RSA, and key store name is server key store. Because why we are giving this name this time? So because we are creating the key store for the server. So that's why I'm giving the name is server key store.jks. Okay, so let me go back to the folder. So here, just enter after giving this, just enter this command. Enter the password. So password, I'm gonna use key store pass. Key store pass again. Key store pass. So this time, you know what? Last time we were just we were not passing anything into this. We were just passing unknown for every option. But the thing is, the first name and last name. What is the meaning of this first name and last name that I missed last time? Okay, so the it means the common name is it is a common name that is called in the short form is CN. Okay, so CN is a typically composed of your host plus domain name. So it means it must be the same as web address you will be accessing when you connect into a secure site. Okay, so like here, so what should I give? Either you can say like your host plus domain name, like something app.mule.com or like app123.com, something like that. But we are showing you on local we are doing everything on local, so it will be local host, it just local host. Okay, then press enter. Okay, so other things, the cn is always important. We need to pass the cn always into these commands. We should not skip this, but if you will skip this, we will get this error, like same like when we will hit the API, we will get like when we will hit our server application from a client application, we will get that error like localhost is not a some name or something, some error will be there. I forgot exactly what was that. Okay, so this is very important. So we need to give always the first name and last name as a host plus domain name. So I'm giving here local host. Okay, so now organization unit, other options are, means it depends you want to give or not, but these things whatever we are providing, these are kind of your information about certificate, who we to whom we are assigning this certificate. It's kind of a, whatever we are doing, it's a kind of a self-signed certificate process. Okay, I will show you the other process also, like I will explain you the there are some authorities to sign the certificate if we don't want to use self-signed certification process, but here we are using a kind of a self-signed certificate process. Okay, so first name last name done. Organization unit, you can give something like MuleSoft Station. Enter. What is your organization? You can give anything. Organization unit, organization. In this also I'm giving MuleSoft Station. Soft Station. Organization, you can give like some IT or anything, but I gave the same name. So just enter. City. City I'm giving like India. State like Delhi. Two-letter country code IN. So everything is correct. Is CN local host, OU organization unit MuleSoft Station, organization MuleSoft Station, city, state, country code, everything is correct, then yes, everything is correct, whatever we provided. Now E is store pass. E store pass. Enter. Okay, so if you see, it created keystore.jks. Okay, if you open it, I have a utility in my system. I have a kind of a software that, one moment, when I open this, it will open by default. It will open a key store. Whatever JKS files, it will open by this key store explorer. It is a kind of a third party software. Okay, so when I pass this file here, it will ask me its password, key store pass, enter. So if you see, alias name was mule server. Okay, so it will show you everything. What is the subject, who is the issuer of the certificate, who is the issuer of this, everything. Certificate hierarchy, what is the public key, if you copy, what is the public key, because when you, if you see this diagram, server send its certificate with a public key to the client. Okay, so what is the public key? This is the public. If you open this, this is the public key. This is the public key that we import. Okay, or that we import. This is the complete public key. Okay, that we use. Okay, so it will show you everything. That's why I downloaded it just to show you. Okay, just close it. We don't need to do anything with this now. Okay, so everything is done. For we generated the key store. Now the second command, export the public certificate from server key store. Server key store, in the server key store we have a public key or a kind of certificate that we need to export. Copy this command, go back to the command window, just copy this here and just press enter. So here alias is like key store export. We are exporting the certificate. This is the certificate name. This will be the certificate name, and from where, which key store. This is the server key store.jks that is available here. The server key store.jks, and alias is mule server. So just press enter. It will ask you the password of key store pass, and so it's exported this certificate. Okay, and now it's done. Now the third step, for import, we will import server public certificate into the client test store. That is here. We will in the client test store. So we need to do this process now. So for that, we have the command, this third command, import alias mule client public. We are giving this is the our alias for the test store, and what will be the keys? That test store name is this, and what is the file? Which server file? Which certificate file? This is the certificate file we are using. So just copy this command and paste into the command window and press enter. And then again it will ask the password. Key store pass. Key store pass. Oh, something missed. Key STOREPASS. KEYSTOREPASS. Okay, it's done. Okay, so it what this command does, it imported the certificate, okay, into the client test store. So now every information is, you can check, owner is CN localhost, this is the issuer, this was the certificate, and it's imported. Everything is correct, right? So just say this is, does this certificate? Yes, done. So we got this. Go back, we got the client test store, and we got everything. Now the thing is, this is kind of, you know, what we say, this self-signed certificate. What is happening here? So when you hit from your like, there is one more thing, like this is the self-signed certificate, and there is some authorities, signing authorities, like certificate authorities who signed certificate, who signed the certificate, and they uh, charge you for that. Okay, and you know, most of the most of the signing authorities, the certificate authorities, they will give you the certificates, and browser automatically, the whatever browser we use, like Google Chrome, Internet Explorer, all these browsers are automatically, you know, authorize those those signing authorities. They have their public keys, so they can easily, you know, they can easily authorize that. Okay, on behalf of, like, not on behalf of means, because those signing authorities, those certificate authorities, give public key. Those signing certificate authorities public key is already installed in our browsers, so that's why we are able to manage these secure communications. Okay, but when we use the self-signing certificate, right, when we do our self-signing certificate, so what happens, we deployed our application with the HTTPS, okay, into like dev environment. So when second app wants to interact with your application that is deployed on dev environment, it realized that your application uh, want HTTPS. So it looks at its you know, at its certificate that is deployed on your dev environment and find its public key. Okay, so this certificate, like the second app say that I was like this certificate says like I was signed for our own signing authority, like a signed certificate, because it is. So second app says it is not trusted authority. I will not trust that. Okay, so now we need to tell our second app, hey, if you trust the certificate, then I will point to this certificate authority that certify this public key. Okay, so whatever public key they have into their certificate. Okay, so so we need to tell our second app that, hey, if you trust the certificate, then I point this CA, whatever CA we use, like CA means like whatever we are signing, through which we are signing. Okay, the self-signing one. So that containing this public key, whatever public key we gave into the certificate that second app got. So then if you trust that, then you can use that public key to validate my first application that is deployed on dev. So second app says, oh yeah, that matches, both the public keys are matching. So as long as we trust the certificate, so as long as we trust this certificate, so we can use HTTPS here. So there is no issues. Everything whatever we are doing in our own controlled environment. So that's why these things are easy. Okay, but when we use CA certification, when we use certificate authorities, okay, so what happens in that case? So in that case means, one moment. So I think I miss one thing. Oh, okay, so the thing is when we hit, like when we hit from browser, okay, like youtube.com, a web server, okay, so what it decided when we don't go for, self-signing certificate. So we have decided that we want to use HTTPS, like not like any website like youtube.com web server. Okay, so they decided that they want to use HTTPS. So they have created a certificate signing request with with key pair. So with a key pair and ask to certificate authorities. There are certificate authority, for example, Google certificate authority. Okay, so they ask them, can you please sign? Can you please sign it? So Google CA authority will say, yes, sure. I have signed your request with my private key. Okay, so youtube.com have private key, public key. They will send, and also Google CA will have their private key and public key. Okay, so Google CA is saying, sure, I have signed your request with my private key. Anyone who has my public key can verify that it is actually me who signed it. So your browser already installed in your system with Google CA public key. Okay, so whenever you will hit that request youtube.com, it will automatically authorize it. It means authorize means it will automatically identify that who you are. Okay, so everything is done. So how, I'm just explaining how it works. Okay, so what is a self-sign certificate? So self-sign certificate is your app, like I explained, your app is deployed in one environment and second app wants to interact with it. Okay, so you have your own certificate authority. So you ask your own certificate authority that please sign my certificate, and they will sign your certificate with their private key. Okay, and when second app will interact with you, they will have a public key, but they will refuse to do a communication because they will say, oh, I don't trust this certificate or this public key. Then you, because it is your own control environment, you will explain to your second app that, look, I'm using this self-signing authority, so this is its public key. So both are same, so you can trust it. So then second application will say, okay, I trust it because both are same. So as long as we are doing a communication over the internet, so we can use HTTPS. So this is simple process that we do. Okay, but one more thing, how I just because we are going a little bit more explanation, so I want to explain a little bit more like about how SSL certificate actually works. One more example type. So you have a client, you have a server. So first step will be your browser request. Your browser requests secure pages like HTTPS, google.com, Yahoo browser, something. Okay, so what it will do when it will request to the server, okay, when it will request to the server, which so server what it will do, what server does, it will send a certificate and a private key to the client, which is digitally signed by a third party, or we call it like certificate authority, or simply can say like in a short form CA. Okay, so server will send you, it means server will send the client a certificate with a public key which is digitally signed by the CA. Okay, so now step number 3, when it's sent to the client, so what client will do, once means client means your browser, once browser gets that certificate, it will check the issuer's digital signature. Okay, who signed that certificate, right? So that is created by CA private key. So all the certificate created by CA's private key. Okay, so it will make sure the certificate is valid or not. As we know, a digital signature is, as we know, the digital signature is created by CA private key. Okay, so when it will go to that CA authority, and that CA authority will check with its private key, okay, the certificate is correct, the certificate is created by me only, so it will validate and client will trust it. Okay, so browser like your browsers, Chrome, Firefox, or whatever browser you are using is previously installed, as already explained. It will be previously installed with many major CA public keys. Okay, there is already inbuilt many public CA means major certificate authorities public keys. Okay, so thus digital signature can be verified. Okay, so once the digital signature is verified, the digital certificate can be trusted. Okay, so after that, what you will see, when you do a HTTPS. Let me open the browser. When you do this HTTPS, when everything is done, when certificate is valid, then HTTPS like this office.com. If you see this log, okay, if you click on this, connection is secure. It will show you because the browser validated everything. Every process is done. So you will see this log that simply indicates the web server's public key really belongs to the web server, not someone else. Okay, so because of this, verification is done. Now it is time to exchange a secret. That will be your next step. Okay, so browser creates a symmetric key. Okay, and it keeps one with itself and give a copy to the web server. Okay, and it will share it to the web server. However, your web browser does not want to send the shared secret key in a plain text. So what it will do, therefore it uses the web server's public key to encrypt the secret, that web server sent back to the client. Okay, so it will encrypt it and then will send it to the web server. So web server will receive it, then web server gets that encrypted symmetric key, and it uses its own private key to decrypt it, like the same thing that is happening. So everything is secure now. They will trust everything is done. So this is the whole process, how C authorities works, how your browser works. Everything is like this. Okay, so I hope these doubts, these explanation will clear so many things. And one more thing, like you keep in mind that HTTPS. Okay, whenever you see this padlock like this, okay, because it's a HTTPS, it only indicates that communication between client and server are encrypted. It does not mean that website itself is safe and good. Okay, it does not mean that it's safe and good. Anyone include like some hackers, they can launch online business or any other websites. Okay, they also can get SSL certificates for their sites. So that's why it does not say that it is safe and secure. It is just saying the communication between client and server is safe. Okay, but it is not showing that it is safe. It is that website is not belongs to any one who is doing any bad activities like hackers. Okay, so when you are doing a online shopping, you still want to use website with good reputation. uh, Means when you are online shopping, you still want to use website with good reputation. So that's why they use this HTTPS and all. If you don't have HTTPS, if you have don't have HTTPS and all, if you have on self-signed certificates, you will get the warnings when you will hit the request. Okay, they will say like the Google browser will say, because they are not validating the self-signed certificate. They don't know who is the certification authority, right? So they will show you that this is not the secure uh, thing. This is not the secure website. Okay, so self-signed certificate says, trust me, I am who I say I am. Okay, when you take the certificates from commercial commercial SSL certificates. Okay, so it means trust me, like if you are taking it from GoDaddy. Okay, so GoDaddy here it means trust me. GoDaddy says I am who I say I am. Okay, so there is the difference. Okay, so, and another difference is that digital certificates from a commercial CA is already known to your browser, because as I already said, your browser is already inbuilt or already installed with public keys of many CA. Okay, so um, when you go to the sign of this kind, like where is HTTPS, they make sure that site look good and more trustworthy. Okay, so that's why this is HTTPS. Okay, so this is small explanation to understand, to give you some understanding about, you know, this certificates and all. Okay, so now let's go back. We created these certificates, or we created the key store and trust store. Now go back to your application. I go to the normal mode. Okay, let me check this application first. Like last time we were using the state listener. These were okay. One moment, I'm just crossing, doing some cross check. Control A, Control I. So that is fine. Listener configuration. Okay, this TLS context, DB config, flow name. I think it's fine. Fine. Save it. Just I will check if it is our last. This is our last application that we used during the debug integration. Okay. Okay. I will quickly deploy it and will show you. I will show you instead of Postman, I will show you from the browser, because because whatever we are doing, it's a self-signed certification process, kind of that. So I will hit the request from browser. So I will show you what warning you will get. Developers don't get chance. Mostly developers don't get chance to work on these things because it's a one-time process. So when you join a project that is literally from scratch, maybe you will get a chance to understand, or you will get a chance to work with your architects or team leads when they will create these certificates. So you can ask your queries, or you can understand the process how they are doing, because in our MuleSoft applications we use some signing authorities to sign our certificates. Okay, every company have some self signing authorities. They send the public key and everything to that to that authorities to sign. Okay. Okay, it's initializing. Okay, it's deployed. So let me hit this request HTTP. So it's HTTP process. Okay, so we were getting this response. Keep in mind that we were getting this response, and when we hit from the browser, when we hit it from the browser, let me copy paste this here. Hit this. Okay, F6, go back to the browser. So we get this. There is no warning, nothing. Everything is perfectly fine because it was HTTP. Information, view site information if you want to see site information. Your connection to this site is not secure because it is a HTTP. So this is kind of message you get. Now go back to application. Now we will I will do one-way SSL process first. So open first this HTTP listener. We will configure this HTTP listener first. So here, edit this connector configuration, make it HTTPS. Port will be same. Go to TLS. Edit inline. There are three options. None means nothing, no TLS. Edit inline, we will add the TLS and key stores. But global reference means we can create a reference like in global elements, we can create a configuration for key store and trust store, and that we can import it here. Like a create a configuration, click on it, it will give you the TLS and all. You can give any name, generic name here. It will create it separately like a global configuration, and that you need to import. But I don't want to do that. I will just create it. I will just do it here with the edit inline. So everything is here. Now go to key store because it's a server application. It's a JKS path. What will be the path? First, I will copy this server key store, copy the name, go back, give in the path because I will explain this. Alias is what was the alias that mule server for the key store. Go back, give the mule server, show the password, key store path, EYSTOREPASS. Okay, that is done. Save this and go back to normal mode in your package explorer. Okay, I will reset window perspective, reset. I will just stop the flow because every time I will save something, it will redeploy. So now go back to the folder, copy this server key store, copy, paste under src main resources. Whatever files related to your API or application, like you need to copy it here. My DB, one moment, we already have some files. I will delete it. Server deleted. Now copy inside src main resources, server key store. So, when I was doing this configuration, I added the file name like in the path into the TLS, just simply like server key store, the file name. I did not give the complete path src main resources because by default, it will understand this file is under src main resources. Although if you have another folder inside src main resources, in that case, you need to give that folder name like here, the folder name / your file name. It will work like this. But we are not using any folder. We are just using directly a file under src main resources. So our path, my JKS file path will be like this. Simple, the file name. Done. OK, everything is done now. Now, what is the next step? We configured this application. We configured the trust store. Now we need to create a client application. Server done. Now we need to do a client application. So let's create a separate flow. This is the flow. And here we'll use an HTTP listener as a source. And first configure this HTTP listener. I don't want to use the same HTTP listener that is here. HTTP listener config. I want to create a new one. I will create it HTTP listener config, HTTP listener client config. Here it will be 8081 is already we are using. So what I will do, I will create this as 8081 and I will change the port for this our server application as 8082. Go back here. I'll change it to 8082. OK. Go back to message flow. Now take a logger, keep it here. What error it is showing? Let me check. OK, path. We need to give the path. I'm giving API / only API / client app. client app. client app done. Now in logger, entry to client app, that is done. Now take a requester, because HTTP requester, a listener is to listen the request to our API. Requester is to request another APIs that is deployed in your any environment or your third party APIs if you are integrating with some other system like a database. Okay. So like if you are interacting with other systems like Salesforce, Jira, ServiceNow, whatever. Okay. So for that to call those ones in your APIs, you need to use HTTP requester. Now configure this HTTP requester. From this requester, I want to call this server application. So for this server applications, we have one moment. Now it is HTTPS, and for this HTTPS, because we configure the key store, it is now and the protocol changed to HTTPS. Okay, so its path is this. Just copy the path and go to the requester. Path path will be here. Okay, and method is get. Okay, payload, we don't want to give any payload because that is a get request and we just want to pass our query parameter. Okay, because that client server, we are interacting with the database, and from database we want to get the data where employee ID is 313. Okay, or like 312. So go to query parameters. This request, HTTP requester, have method, path, URL, body, headers, query parameters, URI parameters. So everything that you need to call an API, everything is available into this requester. Okay. So there is two options. You can switch to expression mode. In expression mode, you need to give a JSON like EMPID colon 312 like this. But when you if you don't want, when we use this, it means it should be a JSON, or if you have only single parameter, then what you can do instead of this, you can go to the literal mode. Go to the literal mode, click on plus and give the key name as EMPID and its value will be like 312. Okay, so there are two options. So I have only single field, then I'm using this EMP. If I have more fields or want to do some validations, okay, if I want to do some validation when passing this query parameter, or I'm reading it from somewhere else, so I can use this expression mode, because in this expression mode I can do all the validations or I can give the default values, but here I cannot give default value. Okay, so best is always use the expression mode. Go back, it will automatically change whatever literal mode you have, it will automatically change to your expression mode like this. Simply like with the Java, EMPID is this. Here, if EMPID, if you are reading from somewhere like where's dot something ABC. So whatever variable we are setting with the name ABC, it will read that value. Or if it is not there, then you can say like default blank. This thing, whatever we are doing this validation, you can't do in the literal mode. That's why we always use expression mode where you can do some validations. Okay, so I'm just giving a simple hard code value here. I'm not read because I'm not setting any variable. I'm just having a logger. So I just give a hard coded value as 312. Okay, so now our request with the query parameter is done, and we have one moment, it stuck. So we have added the server applications path that was API / first DB. Now we need to create a request configuration. Okay, one moment, a little bit stuck. So it is a client application. So in client application, we need to pass the trust store that will have the certificate of this key store with its public key. Okay, it's not opening. Okay, so now click on plus because it's a HTTP requester. Click on plus. Here, HTTP request configuration. We are not giving any paths. Protocol will be HTTPS because server application is HTTP. Host is local host. Okay, and its port is 8082. We have changed it from 8081 to 8084 request. Now we need to go to settings. Not settings. In general mode only, we have TLS configuration. This TLS configuration we need to do is edit inline. There are three options: none, edit inline, global reference. So global reference will create a configuration separately, not here. Okay, so click on edit inline. Everything is here. Path. Path. What is the path? Path means the file name or the file where the file directory. Okay, so let me copy this file name. JKS. I will copy this path here because I will pass this file inside SRC main resources. So this will be the simply file name. It means SRC main resources slash client trust store JKS is the directory. That is the path for our trust store file. Password. Password is same. KEYSTOREPASS. Keystore pass and type is JKS. That's done. Okay. Query parameter is done. Just save this and copy your trust store, copy and paste it inside SRC main resources. It's done. Now everything is done. One-way SSL process, what configurations, everything is done. Now just deploy this application. MyDB POC debug. We'll see. First, I will show you by running the server application what it will give you. I will open a separate browser, Google Chrome, and there I will just copy this path. See, close this one. I want to show you here. Here now it will be HTTPS and port is 8082 and we will hit this one and I will show you what warning you will get because the key store that we are using the certificate is there. It will not, oh, it will not trusted by our browser. So there will be a warning. You will get a error like certificate is self-signed certificate and not signed by trusted CA. So certificate is not shipped with OS, your operating system or like your browser. Okay, so it will quickly deploy and then I will show you. So whatever we have done now, it was one-way SSL. And after this, I will show you this one, two-way SSL, where at server side we need key store, at trust store, at same key client side key store and trust store. Okay. Little bit slow. It started initializing. Now it will starting deployed. Okay. So clear the console. I will just I'll remove the debug point because it's stuck. I will just hit the request here. This is the request, enter it. If you see, your connection is not private. If you see not secure, okay. Yes, if you click on not secure, what your connection to this site is not secure. You should not enter any sensitive information, blah, blah, blah. Certificate is not valid because it is not validating the certificate. Okay, it is not validating the certificate from the server application. Okay, so click, you can see click on certificate here. If you see the CA root certificate is not trusted. the CA root certificate, the client authority certificate, the whoever signed it, it's not authorized, it's not trusted by the browser, because that is our browser doesn't have that that authorities public key. Okay, so we get this information. So how to resolve this? A certificate has to be installed in the operating system browser, in your browser, operating systems browser. So currently we are not covering this, but because it will take too much time, but let's just go to advanced, proceed to localhost and save. This is we are getting the request. Okay, so this is like how we are getting the error in our browser, but the same request when we hit from the Postman, let me show you from Postman, you'll get the response, because if you go to the settings here, SSL certificate verification is off. When I will click it on in the Postman setting, now click it, I will get the same disable SSL verification, some self-signed certificate, SSL error, self-signed certificate. It will also not validate that because it is also a kind of browser. So here in Postman, we have that facility, like just we always put SSL verification as off. So it will work without any error, without showing anything. So if you see, that's done. Now it's time to show or to the complete SSL verification, like one-way SSL. So we call a server application. Now we will call our client application. So client application is with the port, with the path client app, copy this, or I will use now Postman. It's easy. So I will do one thing. I'll don't save. Okay, so I will create one more. Here I will enter this URL. Here its port is 8081 and it's not HTTPS. Client is with protocol HTTP. Okay, so let me hit this one now. So I will put a debug point here. So to show that request is coming here in the client application, hit the request, get method by default. It request came. Now I will put a debug point here because it will call our server application app6 go. So because requester, it's called here the server application. So everything is done. It's trusted. Everything is trusted. Go now. Just click F8. Okay, timeout exceeded. That is also a thing I want to show you. If you see, one moment, F8, fine. So we get the response. Why we got the timeout? Because if you go to the requester, there is some settings. Every requester have a response request fields advanced. So if you go advanced, whatever we will get from this application, output will be a target value, will be a payload. Okay, you can set the output, whatever output you are getting, into a variable also. Okay, instead of payload, then you can set the variable name here. If you don't set variable name, then everything whatever we are getting from server application, it will be under payload by default. So you can access it like payload dot whatever you want. Like our payload is coming like this, payload dot id. So we like our payload is this, so we can access payload dot id in the client application. But if we are setting a variable name here like abc, then how we will access this? Where's dot abc, whatever variable name will give, like abc we are giving, so where's dot abc dot id, like this you get it. Okay, and response timeout. Okay, so you can set any response timeout, like in how much time. Yeah, it should give you the timeout error. By default, I think it's a 30-second. Not sure. Maybe it's less. It show you somewhere. One moment, I will show you that. where exactly it is. Response. This is the response timeout. Request, nothing. Response timeout, nothing is there. So there is by default response timeout. Response timeout in HTTP cluster. One moment. I will show you the documentation actually. So if you go to the documentation of HTTP requester in the MuleSoft, they will show you. I think by default there is some 5 seconds or some 6 seconds time, but you can change it. So this is HTTP connector reference. HTTP connector listener. This is the listener. This is the request configuration. So here name, connection, expiration policy, base path, default headers, send correlation ID, response timeout. This is the response timeout. So maximum time in millisecond that the request elements block the execution of flow waiting for HTTP response. If this value is not present, the connector uses the default response timeout for mule configuration, which is also this 10,000 millisecond. Okay, so this is the default value of a response timeout if you don't give any value. So by default, it's value is 10, this like 1, 2, 3, 10,000 millisecond. Okay, so it is using 10,000 millisecond. That's why we were getting the request timeout. Okay, but if you do it quickly, like for example, if I remove these breakpoints, then it will execute quickly. Let me hit the request. We don't get any timeout option. But when we just click debug point here in server application, click, it is taking some time. I will wait. So I will wait more than 10 seconds. That's already done. Now hit the request. You will get the timeout, failed timeout, because 10,000 millisecond means 10 seconds. That is by default response timeout. So we will get the timeout. Okay, so to avoid that, because some applications take some time, so what we do to increase the timeout option. We go to the response, we go to the request connector. One moment, we go to the request connector, go to the response, and we give the response timeout like I will give 20,000. This is the 20,000. Okay, so if we give 20,000, so if we we put the debug point and we wait for 10 seconds, then we will press F6, then it will pass. It will not show you a timeout error because now the timeout response, the response timeout value is 20,000 millisecond. Okay, so that is the difference. So let me go to, so this was guys, this was all about our one-way SSL. Okay, now I will show you how to configure the two-way SSL. It will also quick one. For that, I will use another application that I created like my SSL two-way API. Go into that. It's this one. Because both I will upload it on Git repository for your reference. So you can test it by your own, or you can correlate with the video. So here, as in the same way, I will create a client application and a server application. So if you see, there are already two flows. One is like I will act as server application, another will act as a client application. So here we need to, if you go back to the diagram, you need to create a key store for server, key store trust store, trust store for server, key store client, trust store client. So for that we have the another commands. So these 6 commands we will use for our two-way SSL. Earlier it was three commands, but now we are doing vice versa. So that's why it's a 6 commands now. Okay, so I think that we will quickly create that, and it will be easy to implement. So now generate, I will open a command prompt, go to new volume SSL2, already created, tested. So I will delete these certificates and I will create it again. Go to command window, CMD. It will open a new command window, or the command window that I used earlier, I will close it completely. Go put to this, copy one by one each command. So here generating a server key store first, server key store. The commands are same, but everything is same. The server key store, copy it, paste it, enter. It will ask you the password. Give the same password. Key, COREPASS. KEYSTOREPASS. Okay, so here, as I told you that this is a kind of CN. The so here you need to pass the value. Definitely it's required because it's a common name, and that is a combination of host plus domain name. Like generally we pass whatever the host name will be for our application. Okay, so like for example, app.com, app.mulesoft.com, whatever. So here I'm passing like localhost. LOCALHOST, localhost. And now organization unit. Last time I gave MuleSoft station. So this time I will give like organization unit. What is the unit of this organization where we are working? So like IT. Okay. The organization name, MuleSoft station. The city, name of your city, Delhi. Name of state, that's same like Delhi. It's an Indian territory. So 2-letter country code, IN, India. Okay, so everything is done. City, everything is correct, whatever we give. Now say yes, everything is fine. Give the same password, key store pass, KEYSTOREPASS. Done. Go back. You got the server key store. Now, second is export the public certificate from server key store. So for that, second command is this. Yes, server public certificate. Copy this command and go to your command window, paste it, enter. It will ask you the key store password, KEYSTOREPASS. Okay, go back to your folder to get the server public certificate. Now the third step, third command is import server public certificate into client trust store, into the client trust store. Till now I'm using the same thing. Whatever I have done for one-way SSL. Copy this third command, paste into command window, enter it. It will ask you the password, key store pass, KYSTOREPASS pass. Done. Everything is fine. If you see localhost IT MuleSoft station Delhi, India, owner issuer. So everything is correct. So trust this. It will ask trust this certificate. Yes, we trust. Done. So you will get client trust JKS. So now the fourth step, we have done same like first one, server key store, server trust store. In the 2 SSL, server key store, client trust store. Now we need to create server trust store and client key store. So go to the fourth command, this one, that will create the client key store. Client key store means this one, this one. Okay, so we'll copy this command, copy it, go to the command window, paste it, give the password, KSTOREPASS, KEYSTOREPASS. Thus, the first name and last name. So here it is fourth step, right? So it will ask you. So here also I need to give localhost, spelling mistake, localhost. Enter organization unit. I can give same like IT, MuleSoft station, city, Delhi, IN. Done. Everything is fine. Yes, correct. So password key STOREPASS, enter, KEYSTOREPASS. Okay, something mistake. KEYSTOREPASS. KEYSTOREPASS. Okay, so go back to the folder. We get client key store. Done. Now we will export the public certificate from the client key store. It's the same process. Everything is doing, but now we have to do everything for client and server. Copy this command and paste it here and enter it. It will create a certificate, that is client certificate. Enter it. Password EYSTOREPASS. And if you see here, this is done, and we are getting, we got, and the last one is sixth command. This one, that is import client public certificate into server test store. Copy this one, paste it into command window, enter it, give the password KEYSTOREPASS. KEYSTOREPASS. Done. Imported. Say yes, everything is fine. Done. Now server test store, server key store, client key store, client test store. We got everything. Just copy these 4 files. 1, 2, 3, 4. Copy this. Go to your Anypoint Studio, paste under SRC main resources folder. That is done. Now go to your server application. Okay, there is a listener. So listener, we are giving like this path, but I will give like server app. Edit the HTTP listener configuration. Give path is 8082 and it's HTTPS. TLS, we need to pass TLS. Is server trust store and password is same JKS, and key store also we need to give this time because it's a two-way SSL. So server key store, mule server alias that we have used in our commands, mule server. For client, we use mule client. So go back to studio. Everything is fine. Just click OK and save. Now come to your client application, this listener. And this one I'm making like CLIent client app, and this listener configuration just edit it. I will say like CLIE client config. Okay, here HTTP, everything is fine. No HTTPS, nothing, just okay. Sorry, I forgot the port name. Oh, it's 8081. That's right. So 8081. Okay. Now come to the requester. So requester path, payload, we need query parameter, nothing we need to give. No payload, we are there is nothing. Okay, so if we give the payload by default payload, so it will go as empty. So generally you can remove it, or if you don't, it's fine. Okay, but edit the request configuration, add the key store and trust store. So here HTTP localhost 8082, trust store, client trust store, password JKS, and same our type is JKS, client store, mule client, password, everything is fine. Everything is configured as it is. Just save it. But thing is, it's path, listener path. We have server app that we need to add into the requester. So here's this path is server app. So done. Now I will copy this client app. I will create a new postman with a get method, and it is http:/local host colon 8081, and it will be client app. This will be our URL. Now go to console, close the previous application, and now debug it. This one SSL1. I will close. I will not use this one. This one my SSL2 API. Okay, and is fine. Apply and debug. I'll put a debug point here at entry point and one in the exit point, and we'll see here set payload is, hey, we have done with HTTPS. So you will get the response with this payload because this payload is coming from server application and we are passing it as it is outside as a output of client application. So once it deploy, we will hit the request and it will trust all the communications and everything will be fine. So it will open the debug perspective because we are running in debug mode just to show you. It is initializing the app, then it will start the application. Starting is deployed, done. Hit the request now with localhost client tab. Send the request. Okay. What is S? Okay, it's triple T, double T should be there. Hit the request. You get the request here now. Click F6, F6, F6. If you see everything is done, going back to client application, it's successfully everything SSL communication is done perfectly fine in two-way SSL, and we get the response now in the Postman. If you see, hey, we have done with the HTTPS. So this was all about one-way SSL, two-way SSL, how we convert, how we use HTTPS in Mule. So this was all about that. So we wrap up the class for today.